Alright class, in this video I'm going to explain the trends in your periodic table, what happens when you go across a group and across a period, and different properties of your periodic table. You see the cartoon on the left, you have your positive and negative particles, and then the teacher's asking, what is it that you guys find so attractive? All opposites attract, right? The positive of the metals will attract with the negative of the non-metals. The first trend we're going to look at is called the atomic radius. Now the atomic radius is the size of an atom. If you remember in your structure of your atom, you have your nucleus, which is where your protons and your neutrons are. I'm not going to write the neutrons because they're neutral charged, but our protons, remember, are positively charged particles. And then you have your electrons. Those are the negatively charged particles, and they orbit around the nucleus. Now in order to figure out why the atomic radius is changing in this manner, if you go from left to right, for instance you're looking at lithium all the way to neon in period 2, the atomic radius actually gets smaller. Now why does it actually get smaller? Let's say we're adding more and more electrons. By adding more electrons, we're going to have a stronger attraction between the protons and the electrons. They're going to want to get closer together. By doing that, our radius or our circle is going to get smaller. So again, more electrons on your outer shell means smaller size. Why does it get bigger when you go down the periods? The reason for that is there's more energy levels. So if you look at, say, lithium only has 2 energy levels with an electron. But if you look at, say, rubidium, that has 1, 2, 3, 4, 5 energy levels. So naturally the electron is going to be further away than the proton, so the radius would increase. Okay, we could also look at the ionic radius. Remember, ions mean charged particles, how positive or negative it is. The size of the ion is very similar to the atomic radius trend. As you go from left to right, this ionic radius will decrease. As you go from top to bottom, the ionic radius increases. The reason why is as you lose electrons with your metals over here, by losing the electrons, they're going to get smaller. Here I'm gaining electrons. By gaining the electrons, the ion will actually get smaller, okay, because you have a bigger attraction between the particles. The next one's called ionization energy. Think of ion and the energy to make an ion. Now for ionization energy is the energy required to remove an electron from an atom. The increasing ionization energy goes from left to right. For instance, if you look at lithium only has 1 electron on the outside. It's going to be pretty easy to just remove that electron because you only have 1 of them, right? However, if you're looking at, say, fluorine, which is actually the most energy required to remove it, I have 7 electrons, right? It's going to be really difficult to remove all 7 electrons. It's a lot easier just to remove 1 than 7. So for this one, just think about the smaller number. Now going with that, you can look at electronegativity. Electronegativity has the tendency for an atom to take in or attract electrons. Now the electronegativity will go from left to right. The most electromagnetic, again, would be fluorine. The reason for that, fluorine has 7 electrons on the outside shell. It's going to want to take in more, and it only needs 1 more to get to 8. You notice 8 is where our noble gases are. Noble gases have full valence shells. So again, if there's a stray electron from another atom, it's going to be much easier for fluorine to attract it compared to, say, lithium, where lithium only has 1 valence electron. Lithium would have to gain 7 more electrons to get to 8, while fluorine only needs to get 1. And that's why the ionization energy is a lot less for lithium as well, because it just wants to remove that 1 electron it has. Any questions on periodic trends? Feel free to send me an email at kaminskyl@hayescisd.net.